Let's also add a set. This set I'm going for will have the standard set operations, union, intersection, and disjunction, which JavaScript sets do not have. It'll also have the standard set manipulation things like has a key, add, remove, and then a transformation for map. I've predefined the interface already, and let's get to implementing it. So I'll start it like the other one. I'll just call it create hash set. It'll take in a key that extends equalable and hashable. It does not take any arguments. We could make it accept an iterable as an argument and then say accept everything that's in there, like an array of some sort. But for now it'll just accept nothing. And this will return a vn set of type key. And we can just return a set. Let's add the size. Let's just add the functions first, so that TypeScript will leave us alone with the warnings. Okay, now that we have filled the thing up, how are we going to implement our set? Well, a set can be built with just a hash map. So that's what we are going to use. I just create a hash table of the same type of key. And this will represent our map. Let's call it a map. The value will be null. We never care about the actual value. All we care about are the keys. Then size can just return the size of our map. Adding a key becomes as simple as just calling map set of the key and null. Checking for the existence of a key becomes a simple of check of map dot get of the key, and then we can do a match on it. And in the success case, we return true. And in the failure case, we return false. And then we can just return this match. Already demonstrating how a match is useful. We can see we never check for any if, else's or something. We can just directly process the result. A remove becomes a simple unset. The map becomes a bit more interesting. And this might also require an extension of our hash table, because I don't believe it has a map function. It does not. Let's add a map function to our map. And this function will accept a mapper that will accept a pair of key value and return a pair of new key, new value. Has implicitly type any. Oh, pair which has a new key and new value. Let's also implement it. How would this look like? Well, it would go through every element in every bucket, and now we're starting to do this a few times, this go through every element in every bucket. So let's get a helper function here. Let's call it iter. And it'll just flat map them all. Like so. Then we can call iter here. We can replace this part here with iter. And I believe we iterated here as well. So we could, instead of doing this stuff here, we could, oh, this goes over the old buckets. Well, we could restructure it and calling it up here, but let's leave it like this for now. And the new map is simply a new map. We can create hash table of the new map with the typing new key, new value, and then iter map for each key value pair. We want to add this to our new map after transforming it. So let's quickly do that. New key, new value equals mapper of pair. Let's just call this pair. And let's set new key, new value. This was supposed to be an n. Did I misdefine this? I did. This should be key and this should be value. Meaning this becomes a key and this becomes a value. And finally, we return this new map. Now we've added our map here. We can implement our map here in terms of the maps map. We only care for the key. We want to create a new set, I guess. Of the t. Let's call this new key. And then this is called map. It should be called for each. In this case, it's just a semantic difference for each. Would be more appropriate though, because this has a side effect. But we want to add set dot add of our, after applying our mapper over our key. And we return this new set. Yeah, let's add the for each as well, actually. Or let's expose the iter simply. Which will return an array of the key value pairs. I'm thinking if this should just accept a function that accepts key value pairs as callbacks. But we'll leave it like this for now. And then we can just return the iter here. The iter is already a flat map, but the buckets here are still our original buckets. So we want to also clone them. We also want to, now here's a question, do we want to change our key value pairs? Because in theory someone could modify our pairs here. So let's also do that. So the bucket will become a map of key value to key value. Well, not map, bucket. Right, so our iter is now type key value. It lost the typing. That's irritating. Okay. Anyway, we have the iter now. And the iter is way more appropriate for this. And let's just consume all of this into here. And we should call a dot for each of it on this, for each. Okay. Now that I'm figured that out, the question is what's going on here? New key, yada yada. So we have a key. Mapper turns the old key into the new key, and then we return a new set of new key. And why is this an issue? Oh, this isn't generic. This is just our key. There we go. The autocomplete before added a generic key here. Okay, now that we've got all the uninteresting stuff out of the way, let's look at the union, which is the simplest of the three. We just create a new set. So a union has the elements from both sets. So we can create a new hash set over our key. And then simply iterate through both of them. So let's also add this iter we just added to our map. Here. Also to the set, which will return an array of keys. I guess could be just an array of keys. Let's define iter as a function that takes map.iter and maps this, takes the key and value out of this, and just leaves us with a key. Now we can just call iter dot for each. And for each key, we can add to the set the key. Repeat this for the other set. And return the set. An intersection contains elements that are in both sets. So let's create a new set. I have no idea what my autocomplete did here, but let's just override this. And return the set. I'm just going to remove the error messages here. How do we find a set that is in both? Well, we can just ask for every element in one set if it's in the other set. If he answers yes, we add it, otherwise we don't. So we can again use our iter. Then we can call the a for each on this. We can get our key. And if the other has this key, then we add to our set the key. And that is the set we'll return. The disjunction is the set that is the set of elements that is in one or the other, but not in both. So here we can just invert this. If the other one doesn't have it, then we add it. And we'll need to repeat this for the other set. And it is of this one has. I'm just extracting it. Then I can call it here as has key of set add. Right, so we're adding it if this one key is not in the others and if the others is not in this one. And that's the set we return. Let's also export this function. And that is it. We have a functioning set now. It's fairly simple once we have a hash map to get to a set, and these functions flow quite nicely if we have the map, the functional mappers over them. Right. If you've got any questions, feel free to leave a comment. Feel free to join my Discord, and see you around.